Deep seas and oceans. The term deep sea or deep stratum refers to the lowest layer of the ocean, located below the thermal slope and above the seafloor, at a depth of 1,000 fathoms, 1,800 meters, or more. Little or no light penetrates this part of the ocean, and most organisms that live there depend on the resources of falling organic matter produced in the illuminated area. For this reason, scientists once assumed that as a result life would be extremely rare in the deep ocean, but in fact studies have revealed that, on the contrary, life thrives in the depths of the ocean. Deep sea areas from Pliny's time to the expedition on the Challenger in 1872 to 1876 that aimed to prove Pliny's view wrong. Bulldozers and deep nets were able to extract living things from all the depths they could reach. However, even into the 20th century, scientists continued to imagine life at great depths as imaginary, or rather illogical. They believed that the factors of eternal darkness, unimaginable pressure and freezing cold at a depth of 1,000 meters acted as inhibitors to the establishment of life in this area. However, the opposite is true. Opening depth, less than 200 meters, is the largest habitat on Earth. In 1960, the bathyscaphe Trieste sank to the bottom of the Mariana Trench near the island of Guam. At a depth of 35,798 feet or 6.77 miles, 10,922 meters, the deepest point of any ocean. If we assume that Mount Everest is completely submerged in water there, its summit will reach more than a mile below the surface. At this great depth, a small semi-flat fish was seen moving away from the depths of the submarine's light. Trieste then retired for a while and the Japanese ROV Kakio became the only ship capable of reaching this depth. The ship was lost at sea in 2003. In May and June 2009, the hybrid remote-operated vehicle, HROV, Nereus returned to the Challenger Deep to perform a series of 3 dives to depths of up to 10,900 meters. It is said that there is more information about the Moon than that about the deeper parts of the ocean. Until the late 1970s, little information was available about the life size of the deep ocean floor, but the discovery of the massive colonies of shrimp and other organisms around the hydrothermal vents. It was the reason for this unknowing trend to change. Before the discovery of deep-sea vents, it was accepted that all living things on Earth derive their energy, one way or another, from the Sun. At the same time, new explorations have revealed the fact that groups of creatures obtain nutrients and energy directly from heat sources and chemical reactions associated with changes in mineral deposits. These organisms thrive in environments that are completely dark and completely anaerobic. In waters with high salinity levels, these organisms depend on hydrogen sulfide as a source of livelihood, a gas that is highly toxic to almost all terrestrial organisms. This revolutionary discovery, which demonstrated that life could exist under these extreme conditions, changed opinions about the chances that there could be life on another planet in the universe. Now scientists think Europa, one of Jupiter's moons, may be able to provide life beneath its icy surface, where there is evidence of a large ocean of liquid water. Did you know that most marine animals have superpowers that we humans don't have? It's called bioluminescence, and it's made up of 2 words, bios, which means life in Greek, and lumen, which means light in Latin. Bioluminescence refers to the ability of some organisms to emit their own light. The word bioluminescence might sound similar to other words like phosphorescent, think glow-in-the-dark toys, or fluorescent, Think text highlighters, but they are very different phenomena. The main difference is that bioluminescence does not require any external source of light such as the sun or a light bulb. A bioluminescence is actually a chemical reaction, more like a glowing,